Okay. All right, what I'm gonna do here is pick up with section 11.4. And in section 11.4, we were dealing with volume and surface area. And already we talked about cubic units of volume, because volume is always going to be in cubic units when we write our final answer, finding the volume of any type of a geometric figure. Okay, and then we're dealing with dimensional analysis, where we were converting from one cubic unit to another. And the one that I left off was I did A and B in class. I'll just do C, but I'm gonna leave D off. Okay. All right, in this case, here we got 400 cubic centimeters, and we want to convert that into cubic inches. Okay, now I know I had better black markers than this. Okay. There we go. 400 cubic centimeters, and we want to convert that into cubic inches. Okay, there is one thing that I do know. Yeah, I do know the fact that let's see, 2.54 centimeters is equivalent to 1 inch. 2.54 centimeters is equivalent to 1 inch. So let's use that. And this will have to be cubed. Okay. We're converting from centimeters, so centimeters needs to be in the denominator. We're going to inches, so inches needs to be on top. And then we write down their equivalents here. All right, 1 inch, that's the one goes here. That's equivalent to 2.54 centimeters. That will go here. Okay. And let's see, bring over the 400 cubic centimeters times, this will be 1 cubed, and inches will be cubed. The 2.54 in the denominator will be cubed. And so with the centimeters, that will also be cubed. And you can see that the cubic centimeters divide out. 1 cubed is 1, so this will be 400 from 1 times 400 divided by 2.54, and that's going to be cubed. So if I do 400 divided by 2.54, that's to the third. Now to 3 decimal places, this would be 24.409. And this will be in cubic inches. Okay. All right. Any questions on just this right here, just converting from, in this case, from cubic centimeters to cubic inches? Okay. And I'm leaving out part D because in this case, part D has a lot going on here with that problem. Because you have to go from, let's see, I know you have to go from meters to centimeters, and that has to be cubed. And then from centimeters to inches, because I know 2.54 centimeters is equivalent to 1 inch. And then 12 inches equals to a foot. So you have to go from inches to feet. That's a lot going on there. So I'm gonna leave that one alone. All right, next we'll look at the non-cubic units of volume. Non-cubic units. Okay. So here's the table that summarizes non-cubic units from teaspoon, tablespoon, fluid ounces, cup, pint, quarts, and gallon, and their equivalencies here. So in this case here for a teaspoon, there's no connection to the unit before that. But for tablespoon, it takes 3 teaspoons to make up 1 tablespoon. For fluid ounces, 2 tablespoons will make up 1 fluid ounce. 1 cup makes up 8 fluid ounces. 1 pint is 2 cups. 2 pints make up a quart. 4 quarts make up a gallon. Okay. So that's the non-cubic units of volume. And then here's the concept map that is related to gallon, quart, pint, and cup. And if you notice on the far, because see, if you relate gallon, that means that 2 quarts, 1 quart is half of a gallon. So 2 half gallons make up a gallon. And then these 4 quarts make up a gallon, and also 8 pints make up a gallon, and then 16 cups make up a gallon, okay? And if you look on the right, you'll see that it's in base 2 here. 2 to the 0, that's similar to 1 gallon. 2 half gallons, that's 2 to the 1. And then 4 quarts, that's 2 squared. 8 pints, 2 to the 3rd. 16 cups, 2 to the 4th. Okay. Now we're going to use those non-cubic units of volume to convert from one to the other. So let's say we have 3 quarts, and we want to know how many cups make up a quart. And 12 cups is equal to how many gallons? Okay. So here's how they did this one. For 3 quarts, we do know that 2 pints make up a quart. Okay, so we're going from from quarts to pints. So 2 pints, that's in the numerator, is equivalent to 1 quart, that's in the denominator. And then 2 cups make up a pint. Or a pint is 2 cups. So the 1 pint is in the denominator and 2 quarts is in the numerator. And as you can see, the quarts and the pints divide out. So it'll be 3 times 2 times 2, or 12 cups. Questions on that? That's part A. Now on the next slide is part B. Now here we're going from cups to gallons. So here we have to use the fact that 2 cups make up a pint, 2 pints make up a quart, 4 quarts make up a gallon. Okay. Since we're going from cups to quarts, this is the way we'll have to do that particular problem. We start with pints to cups, from cups to pints. So the cups goes in the denominator, the pint goes in the numerator. And then go from pint to quart. And again, 2 pints make up a quart. So the 2 pints is in the denominator, the 1 quart is in the numerator. And then finally, 4 quarts make up a gallon. So the 4 quarts goes in the denominator, the 1 gallon goes in the numerator. And you can see that your cups divide out, the pints divide out, and the quarts divide out. So this is what you're left with. 12 in the numerator, and then the denominator, you have to do 2 times 2 times 4. And if you simplify that, reduce that in simplest form, I know that's 12 over 16, but when you reduce it in simplest form, it'll be 3/4. So 3/4 gallons is equivalent to 12 cups. Okay. Any questions on this one? Okay. All right, next we'll look at, well, this deals with liters. Okay. And this also deals with capacity because usually fluids that are held in containers are usually measured in liters. So here we got milliliter, and then 1 liter is going to be 1,000 milliliters, and 1 kiloliter is equal to 1,000 liters. Okay, so those are pretty much the units dealing with the metric system. Okay, there's milli and then kilo, those are found in the metric system, and centi and deci, etc. Now, how they're connected within and between the metric and the customary units of volume. Okay, here's the next slide. Here's that relationship. Of course, a liter is 1,000 cubic centimeters. 1 liter is 1,000 cubic centimeters. Also, 1 liter, if you relate that to quarts, rounded to the nearest million, is this number, 1.056688. And also 1 liter, if you're dealing with fluid ounces, to the nearest million, there will be this, 33.8140227, to the nearest 10 million. And here 1 milliliter is a cubic centimeter. 1 quart, 32 fluid ounces, and 1 gallon is 231 cubic inches. Okay. So those are just a few equivalencies when you're dealing with customary units of volume and the metric system. Okay. And here we can use these to convert into another unit like this one. Y'all have to. Okay, there we go. A biosand water filter is a water purifier that removes bacteria using layers of sand and gravel through natural processes. A particular biosand filter contains 5,800 cubic inches of water. How many gallons of water does the filter contain? So in this case, if we have 5,000 cubic inches, there's an equivalency that says on the previous slide, if we want to find out how many gallons, we're going from cubic inches to gallons. So that means 1 gallon is 231 cubic inches. So that's where this comes from. We're going to gallons, so the 1 gallon has to go in the numerator. The 231 cubic inches has to be in the denominator. Okay. And as you can see here, the cubic inches divide out. That's where that line comes from. You'll be left with 5,800 divided by 231, and it'll be in gallons. So on the next slide that you'll see, it'll be approximately 25.1 gallons. So the filter contains approximately 25.1 gallons of water. All right, any questions about non-cubic units of volume and how to convert those? I don't think you'll have something like this in the homework. I had to look and see, but I try to, pick the ones that were quite easy, something that would be easy for you all to calculate with that. Okay. Yeah. All right, now volumes of figures is what we'll talk about. We'll start with the volume of a rectangular prism. And of course, a rectangular prism is sort of like a box. So if you take a deck of 52 playing cards, stack them up, it would be in the shape of a rectangular prism. Okay. And on the right, you see what that rectangular prism looks like. Because notice that the base, which is at the very bottom, is in the shape of a rectangle. And you do have the length going this way, the width going this way, and the height going straight up and down. And that volume will always be in cubic inches. Okay. Yeah, if you stack them up, it'll be like a rectangular prism. Mm-hmm. Let's take that same deck and slightly push to the side. So now we have what they call an oblique prism. Oblique meaning that it's slanted. Okay. So that volume remains the same. And we still have the same height. Okay. So here, the height is out here somewhere. It's still going to be the same. And the volume will still be the same as well. So in this orange box is the volume of a right or oblique rectangular prism with linear dimensions of length, L units, width, W units, and height, H units. That's given by this. V is equal to L times W times H, cubic units. Okay, keep in mind volume is always in cubic units. So in this next example, in this example, we have a landscaper spreading soil to make a new rectangular lawn with the dimensions of 20 by 45 feet. The soil will be 3 inches deep. The soil costs $15 per cubic yard. What is the total cost of the soil? Now here's what they did. They converted the measurements of 20 feet and 45 feet and 3 inches into yards, okay? Because the soil is going to cost $15 per cubic yard. So we need to convert feet to yards. Now, the 3 comes from the fact that It takes 3 feet to make up a yard. So 20 feet would be 20 divided by 3 yards. 45 feet, if we convert that to yards, we divide by 3, so it'll be 45 divided by 3 yards. And 3 inches, now here, 36 inches makes up a yard. 36 inches makes up 1 yard. So 3 divided by 3 divided by 36. If we reduce that, it'll be 1/12 of a yard. So now, to find the volume, is this. Length times the width times the height. That length is 20.3 yards times the width of 45 over 3 yards times 1/12 yards. That's the height. Now, if you did this in the calculator, you'll get approximately 8.333 yards. And if we multiply that by 15, because the soil costs $15 per yard, per cubic yard, so 15 times 8.333 will be approximately $125. So the total cost of that soil is $125. All right, now here's a problem similar to the one that's in Web Assign. The dimensions of the edges in a right rectangular prism have a ratio of 3 to 5 to 12. The volume of the prism is 1,350 cubic centimeters. What is the length of the shortest side? Okay. Now this is in a form of a ratio, so we need to set this up as an equation. Okay. So I'm going to show you how to do this. I'm going to use n as some type of unit amount, because it says the ratio of 3 to 5 to 12. Because here the length has a factor of 3. So that means I'm letting 3n be the length. And the width has a factor of 5. So that's going to be 5n. That'd be the width. And then that 12 is your height. The height has a factor of 12. Okay. And of course, the formula for finding the volume of a rectangular prism is this: length times the width times the height. And we're dealing with a right rectangular prism. So the volume is length times width times height. We're told what the volume is. The volume of the prism is 1,350 cubic centimeters. So all we do there is just substitute into that into this volume formula. So here, this 1,350 is equal to, the length is 3 times n, the width is 5 times n, and the height is 12n. So that's our equation. Okay, so I got 1,350 here. That's equal to, if I do 3n times 5n times 12n, let's see, 3 times 5 times 12, that's 180. Now I got n times n times n. When I multiply those, this will be n to the third, because n is used as a factor 3 times. Now I need to divide both sides by 80. Let me leave this off. Okay, this needs to be n to the third and divide by 180. This will be 7.5 is equal to n cubed. Okay, but I want to solve for n. It's cubed, so the opposite of cubing something would be to take the cube root on both sides. Okay, so the cube root of n to the third, that's n, but I have to take the cube root of 7.5. And if I round that up to 2 decimal places, this will be about 1.96. And actually, on the graphing calculator, you can do the cube root, because you have to do, I think, second and no. Yeah, you have to press the math key. Somewhere down in that math menu, there is this button. Yeah, press the math.
Oh.
Mhm. And then type in 7.5. Okay. All right, and I'm rounding that to the nearest to 2 decimal places. It'll be about 1.96. That's what n is. But the question that they ask for is, what is the length of the shortest side? Well, the shortest side has to be 3 times n. That has to be the shortest. So I'm going to do 3 times 1.96, which is, okay. And this will be in centimeters. Because the volume is in cubic centimeters, so the shortest side has to be in centimeters. Okay, so that's how we would complete that particular problem here. Okay. Questions on problem number 14.
I mean, would we not have known that just by looking, I mean, not all the math, I guess, but just by knowing 3n is gonna be the shortest of anything else?
Yeah, has to be. Because 3n is shorter than 5n, is shorter than 12n. Any other questions? I had to ask for the longest side, then you do 12 times 1.96. Okay. All right. Let's see, volume of a prism. Now, the prism doesn't necessarily have to be a rectangular prism. It could be, the base could be anything. It could be things like a hexagon, or it could be a triangle, or anything. And I'm gonna skip through these because this just shows you that it could be, the base could be something like this. Here, file size. Okay. Of course, you can see what that looks like for the base. Okay, and that would be the formula. Volume is equal to the base times the height, and it's in cubic units. Okay, the base could be anything like a triangle. It could be a square, of course, or it could be a circle, or probably a triangle, or a pentagon or a hexagon. You pretty much have to know how to find the area of that particular base is, because the formulas are different for the base. And of course, the height goes straight up and down. You'll take that area of that base and multiply it by its height. Here's an example of just that. A hexagonal aquarium provides multiple views and is suited for desktops or small places. A hexagonal aquarium, this right here, hexagon, that's 6 sides. A 6-sided aquarium with a height of 15 inches has sides with a length of 14 inches and what they call an apothem, A-P-O-T-H-E-M, of 12.1 inches. Okay. Now you probably haven't heard of these words before, especially this word, the apothem. Let me take a minute to explain what that means. Or what it looks like. Okay, let's say I had a hexagon. Here's a 6-sided figure. And what I mean by regular hexagon, that means all the sides have the same length. But what an apothem is this. It's that line segment that starts at the center of the figure, and it will be at the midpoint of one side. Okay, that's this right here. So we call that the apothem. And I hope I'm pronouncing that word correctly. Yeah, starts at the center of the hexagon of the geometric figure, goes to the midpoint. Okay. And one guideline for determining the number of small community fish in an aquarium is 1 inch of fish per gallon of water. The average length of adult neon tetras is approximately 2 inches. I don't know if that's relevant to this problem. But according to this guideline, what is the maximum number of neon tetrafish this aquarium can support? And they do give you the hint that 1 gallon is equivalent to 231 cubic inches. Okay. All right, here we go. So the maximum volume of water in that aquarium is going to be this. The volume is equal to the base times the height. But here, since we're dealing with a base, an aquarium that has the base of a hexagon, we have to use this formula. 1/2 times the P, which is the perimeter of that hexagon. That's the distance around the entire geometric figure, times the apothem, which is your A. And then that's multiplied by the height. Okay, so here is where the substitution comes in. We've got 1/2. The perimeter of a hexagon, now here the hexagon that I have up here has 6 sides. And each side was 14 inches. It has sides with a length of 14 inches. So it's 14 all the way around. there's 6 sides, so it'd be 6 times 14 times the apothem, APOTHM. You were told it was 12.1 inches, so that's where the 12.1 comes from. And the height is 15. That was also given to you as well. So when we simplify this, okay, I know we can do 6 times 14, that's 84 times a half. That would be 42, then 42 times 12.1 times 15 would give you 7,623 cubic inches. And then we convert that to gallons, because we were told that 1 gallon is equivalent to 231 cubic inches. So we're going from cubic inches to gallons. So the 1 gallon goes on top, the 231 inches goes on the bottom. So we're going to have 7,623 divided by 231, and this will be approximately 33 gallons. Okay. So here they're looking for the number of gallons, that the maximum number in gallons of water that in the aquarium, that would be 33 gallons. Okay. And then on the next slide, they say an adult tetra that is 2 inches long requires 2 gallons of water. Since there are 33 gallons, we divide by 2. So 2 gallons per fish into 33 would be 16.5 fish. Okay. And here they're rounding down since we have a decimal. But under those guidelines, the aquarium can support only 16 adult neon tetras. Okay. All right, that was example 53. Any questions on that? Okay, let's look at one of the problems that's in the homework. Okay. Now, the homework is kind of iffy with this particular figure, because there are 4, I think there are like 5 or 6 parts to that. And this is only part D, finding the volume of the prism. Okay. Now, let's take a look at what we already have. Okay, so we do have a prism that looks like this. The base okay, so this height is 18. This is 15. From the center here to the side perpendicular to that, 10.3. And here we want to find the volume of that prism. Okay, so let me stop sharing my screen. Now let's identify what we already have in this figure. We do have a height, that's 18. And we do have that A, which is that apothem right here from the center to a side perpendicular to it. That's your A, that's 10.3. and the length of this side on this pentagon, and it is a pentagon because it has 5 sides. That's 15. Okay. Now, to find the base, we have to use this formula. 1/2 the perimeter times A, which is the apothem, because it is a regular pentagon. We have to use that formula. But I need to find out what that perimeter is going to be. That pentagon has 5 sides, so the perimeter would be 5 times S. The perimeter is 5 times S. That's the distance around this figure. That 5 equal sides, so it'll be 5 times S. Now, the length of that side was 15. So if I do 5 times 15, I'm going to get 75. So no, the perimeter of the base of that prism is 75. So now the next step is to find the area of this base. Okay. So that's 1/2 times the perimeter was 75 times the apothem, or that A, that's 10.3. So now we got to do 1/2 of 75 and 10.3. Now this is what I come up with, 3. Yeah. And since it's a base area, it's going to be in, and the measurement unit is feet, so it's going to be in square feet. Okay. So now we can find out what the volume is. And the volume is simply base times height. We found the base to be 386.25 times the height. The height here is 18. Yes, that's it. And the volume is going to be in cubic feet. Okay. So that's how we find the volume of that rectangular prism. Okay. Here I'm listed what's given to us. First, I had to find the perimeter, because the area of the base of that base in this prism, which is a pentagon, uses this 1/2 P times A. So I have to find the perimeter first before I can find out what that base area is going to be. And then volume would be base times height. Find out what the base is, multiply that by the height, that will give you the volume. All right, any questions about problem number 7D? Sorry about that. And for those who are Zooming, I apologize too. All right, next we'll look at the volume of a cylinder. And usually a cylinder is in the shape of a can, because you'll have the circle, you have the circle on the base will be in the form of a circle. And it does show a circle with the radius of R units, and the cylinder with the base that has the radius of R units and the height of 1 unit. And of course, the area of a circle is pi times the radius squared. Pi r squared would give you the area of that circle. Okay. So if you keep stacking many circles, you have a cylinder like this, where the R units, okay? And here they stack, let's say units of circles are 4 units high. That would be a height. And that will lead to this formula. At the very bottom in the orange box, the volume V of a right or oblique cylinder with radius of R and heights of H units is given by that formula. Volume is equal to pi times the radius squared times the height. And it again will be in cubic units. And of course, the height of the cylinder is the distance between the parallel planes that contain the bases. So these are my bases, the top and the bottom. This is the height, that's the distance there. And the same here if it was a right circular cylinder. Right. And forgive me for this particular cylinder, it looks lopsided, but the diagram shows a right cylinder. And let's say I want to find the volume of that cylinder. All right, and let me see if I can draw a better cylinder than the one that I have up here. And from the center to a point on the circle, that radius is 2 feet, by the way. And the height is 3 feet. And I want to find the volume of that cylinder. And of course, to find the volume of any cylinder, or right circular cylinder, we use this formula. V is equal to pi r squared times the height. Okay. All right, now pi is approximately, as a decimal, 3.14159. That's what pi is. And then times the radius, here's the radius from the center to a point on the circle, that's 2 feet. So that's going to be 2, and that's going to be squared because the radius is squared, times the height. Height goes straight up and down. That's 3 feet. Now, if you want to, you could square the 2. So I'm going to bring down 3.14159 times 2 squared, that would be 4. And then if we multiply that through, all the way through, and I think they want this to 1 decimal place as the final answer. Yeah. And I think this is in feet, so the volume has to be in cubic feet. So the volume of that cylinder is approximately 37.7 cubic feet. All right, any questions about problem number 37? Now let's say you had an irregularly shaped object and we want to find its volume. Here's where Archimedes' principle comes in. It states that the volume of an object is equal to the volume of water displaced when you submerge the object in water. And this will allow you to find the volume of an irregularly shaped object using a procedure called the displacement method, as you can see here. Okay, you're starting off with a certain amount of water, and you're going to fill it up to at some particular unit on a what they call a graduate cylinder. And then let's say we put this right here represents the original volume of water in that cylinder. And then let's say we put a rock in that cylinder. Of course, the rock goes in, but the volume, the water rises up a bit. You'll compare the difference between the height of the original water and the height of the water is after you place the rock in. That difference, which is between these two dotted lines, that represents the volume of that rock. Okay. Okay. And that's the procedure there, just telling you what they're doing here. All right, so now in this case, let's say a graduate cylinder is a right cylinder with a marked scale to make accurate liquid volume measurements. So in this figure, a graduate cylinder initially contains 200 cubic centimeters, as you can see here. We drop a rock in that cylinder, so now you see the water level has risen. And let's say we want to find the volume of that rock. Well, the volume is 200 cubic centimeters. Now, the combined volume of the rock and the water, it has risen to 260 cubic centimeters. I don't know if y'all can see this, but this is at 200, this is at 220, 240, 260. Okay, so now with the rock in it, the water has risen to 260 cubic centimeters. So when you subtract 200 from 260, that means that the volume of that rock will be 60 cubic centimeters. Okay. All right, any questions on that example? Okay. All right, now let's look at pyramids and cones. Okay, and their volumes as well, and their formulas for finding the volume. Okay, here they're deriving a formula for the volume of a rectangular pyramid. Okay. So here we're going to begin with a pyramid like this one here, and then create a prism with an open top with the same base and height as the pyramid. And in this, they're going to fill 3 pyramids with rice into this rectangular cube that you see here. And then if you empty those 3 pyramids into the prism, you'll see that it'll take 3 of these pyramids to fill up this rectangular, this cube. So in this case here, that's where the volume of the pyramid is derived. Because if you recall, the volume of any rectangular prism is the base times the height. But here you have to do 3 pyramids to fill up one of those rectangular prisms. So the volume is going to be 1/3 the base times the height. And of course, the base could be things like a rectangle or a triangle or a hexagon or a pentagon. You have to first find the area of the base for that and then use that formula. Now for a cone, now a cone is going to be 1/3 of a circular cylinder. So that'd be 1/3 pi r squared times the height, also in cubic units. Okay. So let's say we had this. A regular pentagonal pyramid has a height of 10 centimeters, sides of length 12 centimeters, and an apothem of 8.3 centimeters. Find the volume of that pyramid. So you can see the base is right here on the left. Each side, there are 5 sides, each 12 inches, 12 centimeters. The apothem is 8.3. Here, the height is 10. So on the next slide, we use that formula. Volume is equal to 1/3 the base times the height. Now the base, here we bring down to 1/3, but that base is going to be 1/2 P times A. P is the perimeter of the base times its apothem, and that's going to be multiplied by the height. The perimeter, that's 5 times 12. Each side is 12 and 12, 12 centimeters times 5, and then the apothem was 8.3. All that's in parentheses, times the height, which is 10. And then when we simplify all of that in the parentheses, it would be 830 cubic centimeters. So that means that the volume of the pyramid is going to be 830 cubic centimeters. Okay. Questions on this? Okay. In this one, we have a diagram representing a regular pentagonal pyramid, and the measurement unit is going to be in feet. Let's say I want to find the volume of that pyramid. Okay. This height is 22. Now, I know this is going to be hard to see, but this line represents what they call the slant height. We're going to talk about that when we get into surface area on Monday. That's 25.2. All right, there is a big problem here. We don't know this length right here. It's called the apothem. We don't know what that is. But I do know something else. If I draw this out, take this part out right here, this will be a right triangle. And let me do a different color here. From here to here and to here. That's the right triangle. And I know that's 22. And I know this is 25.2. I need to find out what this length is. That's the A. Now, in this case, I need to use, and I don't know if y'all remember this, we call that the Pythagorean theorem for a right triangle. For a right triangle, the square of the hypotenuse is always going to be equal to the sum of the squares of the lengths. And the longest side is the hypotenuse here. That's C. So that's going to be D, and A is what I'm trying to find. So I'm going to substitute into this Pythagorean theorem. A is what I'm trying to find, that's A squared, plus B, that's 22, and that's squared, that's equal to C, which is 25.2. That will be squared. So here, if I square 22, 22 squared, that's 484. And that's equal to 25.2. And if I square that, that'd be 635.04. Okay. And now I need to get A squared by itself. If I subtract 484 on both sides, that will mean A squared would be equal to, I've already worked this out, 151.04. And to find out what A is, the opposite of squaring something will be to take the square root of 151.04. So this would be approximately 12.29. So this apothem right here, that's 12.29. Okay, so now I can find the perimeter first. That's 5 times S. And I've got to mention that this is 18 right here. The length of the side is 18. So 5 times 18 would be 90. So the perimeter there would be 90. The base is 1/2 P times A. So if I do 1/2 times the perimeter, that's 90, times the A, which was the apothem that I was trying to find, that's the 12.29. So if I multiply all that out, that would be approximately 553.042. That's the base. And now for the volume, that's 1/3 the base times the height. So 1/3 the base was 553.042 times that height. In this case, the height there is 22. And this will be approximately, to the nearest whole number, 4,056 cubic feet. Okay, so that is the height, the volume of that cylinder. And the problem with that was, we didn't know what the apothem was. It wasn't given to you. So that's why we had to use that Pythagorean theorem in order to find out what the apothem is. This is one of those cases that where one of the sides is not given. You have to go through the use of the Pythagorean theorem for that. I do have another problem, somewhat similar to that, but we'll cover that on Monday. And then we'll go into surface area as well. All right, make sure your name's on the sign, your signature's on the sign-in sheet. And for those of you who are Zooming, make sure that you type your name in the chat. I can count you present. And-
Sorry, I didn't hear, I'm sorry. Is that quiz opening up today, or the exam, something's opening today?
Quiz 5 is open. Come on, Matt, before I sign off, quiz 5 is,
Yeah, I
Yeah.
saw quiz 5.
yeah, it's open.
Can I,
But quiz 4 is due this Saturday.
okay, can I email you those, the ones that I was talking about on Wednesday, on Monday that I was telling
Yeah.
you about?
That'd be fine.
Okay. Thank you.
Mhm. All right.